Welcome everyone to PBL. Here we will solve some of the interesting questions that you might have difficulty to solve. So here we have the question: find find the empirical formula of the compound which contains carbon. Here we are given with percentage of carbon, hydrogen and chlorine. But in the options we can see oxygen also. It means that we in the given compound we have carbon, hydrogen, chlorine and oxygen. So here we are given with the percentages. When we are talking about mass percent tells us about the mass of the component, like the element, in this case element in grams, in 100 gram of the compound. So here, if we are talking about a percentage, then this would be 16.27 gram of carbon. We will make a table over here. Here, in the first column, we will write down the elements. Here, we have the elements carbon, hydrogen, oxygen, and chlorine. Then we will write the given masses in grams. So here, if we have 16.27 mass percent, the mass of the carbon would be 16.27 gram. Like that, hydrogen will have 0.68 gram and chlorine will have 72.20 gram. So here we have all the masses in grams in total 100 gram of the compound. Now we need mass of oxygen. So if we need mass of oxygen, we have to minus the masses of carbon, hydrogen and chlorine out of the total mass. So total mass minus mass of carbon plus mass of hydrogen plus mass of chlorine. So here total mass is 100 gram and mass of carbon is 16.27, mass of hydrogen is 0.68 and mass of chlorine is 72.20 gram. 100 gram minus 89.15 gram, that is equal to 10.85 gram. So we have mass of oxygen is 10.85 gram. Now we have mass, we will write here the molar mass, which is represented by capital M and its unit is gram per mole. So here we will write the molar masses. For carbon it is 12, for hydrogen it is 1, for oxygen it is 16 gram per mole and for chlorine it is 35.5 gram per mole. Now we will calculate the number of moles, that is equal to mass divided by molar mass and its unit is mole. So here we have 16.27 divided by 12. The moles will be 1.36 moles. Like this, we have 0.68 divided by 1. So we have 0.68 moles. Like that. So we will divide 10.85 divided by 16, that is equal to 0.678. Then we have 72.20 divided by 35.5, that is equal to 2. Now, to calculate the molar ratio, we have to divide all the moles by the lowest number of moles. Here we have the lowest number of moles at 0.678. We have to divide all the moles by this number, 0.678. We will get here 2. Then here is 0.68 divided by 0.678. It is equal to 1. Then we have 0.678 itself and we have to divide with its lowest number of moles, that is 0.678, and we have here 1. Then again we have to divide 2 divided by 0.678, that is the lowest number of moles. It is equal to 3. Now as we have the molar ratio in whole numbers, we have the molar ratio for carbon, hydrogen, oxygen and chlorine as 2 is to 1 is to 1 is to 3. Then we can write the empirical formula for this compound as, like, we have to write it in sequence like carbon, hydrogen, oxygen and chlorine from the electropositive one, starting from the electropositive atom to the electronegative atom. Then we have carbon 2, hydrogen is 1, oxygen is 1 and Chlorine is 3. So we have the formula C2HOCl3. C2HOCl3 is given in option D. Therefore, the correct option for the given question is option D. The empirical formula for the given compound is C2HOCl3. Thank you.